All right, guys, this is part two for the day two. And we're going to talk about what's the difference between mass and weight. Mass is the amount of substance, and we do this by determining its mass, and we'll show you how to do that in a minute. But when we talk about mass, we're talking about the amount of substance, and we're going to find out that's going to be the total number of protons, neutrons, and electrons in the atom or in the substance. So that's mass. Mass has a volume. Now, weight is the force of an object. Force is gravity pulling us down onto a flat surface. And that is that force, of the material, the substance, is on a surface. That's what we think of as weight. And so when we measure weight, we step on a spring scale where our substance, or our bodies in this case, presses on the scale, and this dial moves to tell us our weight, which is the force of our bodies on that scale. Now, to measure mass, we use a balance. And we have two sides, and you put the unknown mass on the left, and we use calibrated masses on the right to make sure that becomes even, that they're at even level. And so that's how we measure mass. And we measure mass using the unit gram or kilogram. In the imperial, it is ounces, but in this class, we're always going to use metric. And so here's the metrics, and we'll talk about prefixes. In metric system, we use prefixes to designate the power of 10. If we use centi, that's 1 over 100, or 10 to the minus 2. This is scientific notation, folks, and you need to know scientific notation, which we're going to explain a little bit later. Kilo is 1,000, or 10 raised to the third power. 10 followed by 1 followed by 3 zeros. Or with centi, it's 1 over 10 followed by 1 followed by 2 zeros. I hope you get the idea on this. And you need to know this table where M is mega, K is kilo, deci, centi, deca is not used so much. We use it to define liters, but honestly, we don't use deci that much. Milli, micro, nano, and pico. Those are the most common metric prefixes. And so we've got a question on this: how to convert 20 centimeters to meters and 0.534 liters to milliliters. So centi, come on, pencil, is equal to 1 over 100, or say 1 meter is equal to 100 centimeters. So when we convert 20 centimeters to meters, I'm going to use this fractional form. 1 meter is to 100 centimeters. And that will give me 0.2 meters, or 0.20 meters. And that's how we convert meters to centimeters. And we're going to convert 0.534 liters. That's supposed to be a 4. And again, I'm using this fractional form. We'll talk more about this in a minute. And this is 1 liter, and we have 1,000 milliliters. So 1 liter is equal to 1,000 milliliters. And the answer is going to be 534 milliliters. So I hope you guys can understand how we got those numbers. Now, when we talk about dimensional analysis, and this is what it is that we're using all these different conversion factors to figure out what we have. So in this question, we have 5 milligrams of tar. If one cigarette has 5 milligrams of tar, 0.4 milligrams of nicotine per cigarette. And we want to know how many cigarettes would you have to smoke to coat your lungs with 8 ounces or half a pound of tar. And this is what most people go through if they smoke a lot. So 1 ounce, and we need to know the metric system for this, and that's going to be 28 grams. And I know that. And then we know that 1 gram is equal to 1,000 milligrams. These are all our conversion factors. And from this, we know that 5 milligrams of tar is for 1 cigarette. Nicotine, we don't care at this point. So 1 cigarette, I'm going to call it CIG, is equal to 5 milligrams. Now, how I'm going to set this up is that I want to make this into a fraction. So I'm going to divide both sides by 1 ounce. So 1 is equal to 28 grams over 1 ounce. And then 1 is equal, if I divide both on this one, divide 1,000 milligrams by 1 gram. That's going to give me 1 is equal to 1,000 milligrams over 1 gram. And this one is that if I divide both sides by 1 cigarette, 1 is equal to 5 milligrams over 1 cigarette. And of course, I could flip this and go 1 is equal to 1 cigarette per 5 milligrams. It doesn't matter how we write the fraction, as long as you get the 1 and the 5 on the right side, you got the conversion factor. And this is what we mean by conversion factors. So what we're going to start with, and I'm going to show you on the next slide, is that we start off with 8 ounces of tar in the lungs. So this is 8 ounces of tar. And for every 8 ounce, for 1 ounce is equal to 28 grams. So we're going to take this, and as you see down here, the ounces cancel, and we end up with grams. Take this over. For every gram, we're going to have 1,000 milligrams. So we're going to get rid of the grams, as you see down below, and we end up with milligrams. So this is still tar. So we've got so many milligrams of tar. So we're going to take this and figure out how many cigarettes that is. And so we're going to divide each. So 1 cigarette is equal to 5 milligrams. So we actually do a division. And we're going to end up with the answer. If I get my handy dandy calculator going. So 8 times 28 times 1,000 divided by 5. I should end up with an answer of 44,800 cigarettes. That is a lot of smoking. Or you could do it 1 step at a time. You take the 28 times 8, you're going to get 224 grams. Multiply by 1,000, you get 224,000, and then you divide by 5 to get the answer, which is, again, divide this by 5 milligrams per 1 cigarette. Milligrams cancel, end up with cigarettes, and you're going to get 44,800. And this is cigarettes. So they did a lot of smoking to get that. Now on this, I want to make sure that the numbers on these units, the numbers in unit can be separate. We always say add the units. We actually what we mean by multiply. So 56 meters is 56 times meters. The unit goes with the numbers. We don't want the numbers naked. They have to have some type of unit because it's telling us what type of measurement we're making. Cross out the units that are on different sides of the line. Answer must be in the requested unit only. And we've got to remember you always need to show your work. And we're going to have problem set later to help you with this.